Let's have a look at the system bus. Now the system bus is made up of three different buses: an address bus, a data bus, and a control bus. So let's just have a brief look at those. We've looked at them before, so we don't need to spend a long time on them. But first of all, the address bus. This is what carries addresses of memory. For example, when the CPU is doing a calculation, it doesn't always just load the number of this. Let's say you want to add two numbers, 15 and 16. All right. So it doesn't just load the value of 15, it loads the address of the memory location where 15 exists. And so it has to carry a lot of address information back and forth. So it does that through the address bus, and we've looked at that a little bit before. Here's the address bus. The address bus in today's computers are typically 64 bits. That means that we have 64 address lines going from the CPU to the to memory. Now the clock that runs the address bus runs outside. This is the external clock, and that's one of the reasons we need cache, because that L1, L2, and L3 cache can load a whole bunch of addresses all at once so that we have faster access to them. Remember that the CPU is going twice as fast, at least, as RAM can go, and so that's why we want to be able to load a whole bunch of it at once, because it is running by the external clock speed. So 64-bit address buses can access about 16 terabytes of memory. Now, data buses do carry data. Data buses, again, if you look back here, carry data back and forth between RAM and the CPU. So an address bus will call a certain location, and the data will come back to that CPU. So again, we are dealing with 64-bit computers, but this time we're talking about how many operations. So if we have a 64-bit data bus, we can typically perform operations at 64 bits of data at a time, rather than the earlier 32 or 8 or 16 or whatever it was. So that means that this is one of the reasons that a faster, I should say a higher bit width of your computer is much faster, because it can move data around much faster, because it has a lot more lines that can move data all at once. Finally is the control bus, and this is what moves things like the interrupt requests, for example, between the processor and other devices. So for example, if I press a key on my keyboard, it doesn't matter what's going on in my CPU, it listens to that interrupt request. And it says, oh, you have something important. Maybe you pressed the escape key and you want to stop processing whatever I'm processing. So that is the bus that controls all of these communications between devices and the CPU on your computer.